So, hello and welcome to our today's webinar. My name is Udo Skerdi and I'm your moderator for today. This time we want to talk about the perfect match of EXACTCAST KMV XL risers and the EXACTCAST padding technology, which make a really powerful team with a lot of opportunities and advantages. At first, I want to introduce to you our today's speaker, Mr. Imanol Ortiz. He's a member of the ASK feeding system team for over 6 years now. Before he started his career in the ASK, he worked for a foundry in the product engineering and calculation department. So he knows really much about the need for innovative and creative solutions in the casting process, and now the critical point in the design to cost decision. As you might have guessed from his name, Imanol is Spanish and lives in Bilbao. He takes care of all the riser and filter issues of our customers in Southwest Europe. This means already a lot of traveling, but in his spare time, he likes to travel even more and further. Please allow me also to introduce myself very briefly. My name is Udo Skerdi, and I'm responsible for the global riser product management at the ASK Chemicals. I'm now 60 years old and have been dealing with the subject of risers since 1988, so really a long time. I hope you feel comfortable with us and we can meet your expectations for today. Before we start, there are some things to know how this event works. The protection of your personal data is our top priority. Therefore, your name and pictures, including video streams, will not be visible. There's also no audio connections available, only from the presenters of this webinar. Nevertheless, you can and should ask questions. If you have questions, please write those in the chat of the Q&A section in the bottom right area of your screen. If you use a mobile device, the chat will be accessible by clicking on the green arrow. We will try to answer all your questions in the Q&A session following the presentation. If the time of the webinar is not sufficient to answer all your questions, we will be happy to answer them personally afterwards. A recorded version of this event will be made available for you in the following days. Please check out our website for more detailed information and the latest news. So those were probably the important things. Now we can start with the absolute most important thing, with our webinar. I wish us a stable internet connection because we are really live today. Let's go. I hand over to Imanol and hope we will enjoy the presentation. Imanol, please.
Thank you, Udo, for this kind and complete introduction. Welcome, everyone, again. So here we have the agenda for today's webinar. We will start with the basics riser technology, then followed by the EXACTCAST KMV technology. Then we will talk about these EXACTCAST paddings. And then, of course, we will explain how this perfect match works together. And then this will be supported with some success stories. And we will summarize the event with some conclusions. So to begin with, going with these basics of the riser technology, we have to consider these risers or feeding devices as part of the mold, together with the casting and the metal temperature. This metal temperature is one of the key influencing factors when talking about any feeding device, And here in this graph, we can explain how this temperature has a quite impact in these feeding issues. So here we can see the thermal curve of low carbon steel. And during this solidification process of this metal, we can identify three contractions. First of all, we have the liquid contraction until the liquidus point. Then we have a solidification contraction. And then at the end, we have the solid contraction. In the end, when we are talking about feeding devices or risers, we are just taking into account that we are trying to solve the volumetric defects called shrinkage only in the solidification contraction process, just in the middle of this curve. Each metal has its own curve, so it's important to understand how each metal has the cooling curves. So the use of these risers or feeding devices is just to compensate this shrinkage that in case of not using any kind of extra material or feeding devices, we'll have these void areas or shrinkage defects in our castings. Now, talking now particularly about the EXACTCAST KMV XL technology, it's important to know that this technology has two important aspects. One is the insulating capacity that the material has. This is thanks to a special raw material used in the composition that is a very low weight material with a very low density that has this insulating capacity. This is not the only property from the material, because this KMV XL technology also works with the exothermic power. So in the end, both combined, the insulating capacity together with the exothermic energy has a very good performance. Together with the material, we have also to take into account the sleeve design as another key point for the success of these products. If we compare the performance of the natural riser made out from the mold to one mini riser, for example, like the one we can see on the right, we see that the performance is quite big when we change the geometry and we add this covering material to the feeder, having these both properties, exothermic and insulating capacities. So once we understand more or less the basics of this technology, we are now ready to cope with the main challenges that the customers at the foundries has nowadays. One of the most important one is the volume savings and the yield optimization. This is not only to improve the process of the foundries, but also because in the current situations that we are now living in Europe with the raw material increases, the energy costs, etc., this is really an important point that the foundries are really suffering. So all these changes from traditional feeding systems to the new KMV XL technologies will bring to the foundries the possibility to reduce the feeding systems with great success and not compromising the quality of the castings. Also, thanks to the development of different formulations for these KMV XL risers, we have also the possibility to solve and reduce the fluorine defects in the surface of the castings. This is mainly due to the accumulation of this ingredient, this particular component, the fluorine, in the sand circuit, and the fact of not having fluorine in the formulations brings the foundry the possibility also to reduce these defects. Also related to the fluorine content, the graphite degeneration is also solved when not using fluorine content in the recipes from the KMV XL risers, but also these problems can come from the excess of exothermia. We have to remember, as we mentioned at the beginning, that the KMV XL technology is based also in the insulating capacity. This means that we do not need this extra heat sometimes to remain the metal liquid inside of the riser. So this means that having this insulating property in the material can also be beneficial when having this graphite degeneration. As we were mentioning, the fact of reducing the volumes from the feeding systems and going from traditional feeding solutions to the KMV XL with less volume, we also have the possibility to reduce the neck sections of the feeder and the casting. These particular areas has a lot of differences when using a traditional fiber solution compared to the KMV XL riser. For example, when using the traditional systems, we have wider necks, and in the end, in that areas, we will have longer solidification times. This will result in having a grain size quite different to the grain size that we would have when using the KMV XL risers with the smaller necks. In the end, with the traditional solutions, we will have a gross grain size that in the end is a matter of quality, that when having this gross grain size, we can have more likelihood of having cracks when machining. So in the end, this is a quite quality advantage, the fact of using the KMV XL risers. Also linked to this idea of reducing the necks, not only the solidification time will be less when using KMV XL risers, but also the possibility to have segregations and precipitations of other materials in the neck area. Here we have an example of a super duplex 6A alloy in which a trial was done with two similar feeders. One was made with a traditional sleeve and another one with a KMV XL riser to compare this effect. We can see in the micrography how the segregation and the precipitation is much more when having these big neck areas. So in the end, it's not only a fact of reducing the solidification times, but also the probability of further defects that may appear with these precipitations. Also, these products has some environmental improvements. The KMV XL risers are products fiber-free, so there is no harmful fibers containing in the recipes. We have the possibility, as we mentioned, to have these formulations with no fluorine in it, not only due to the quality aspects that we mentioned before, but also because in the end, the accumulation of this component in the waste disposals are more and more difficult to handle, and in the end has an extra cost for the foundries and is not good for the environmental. So also have the fact of not having any fluorine in the recipe will also be good for the environmental. Also mention that the residual material from the risers once they are burned is that this material is 100% recoverable. So we have no problems if these materials are included in the sand circuit, although due to the low density of this material, part of it will be go away through the aspirations during the cycle process. Now we will go through the paddings, the EXACTCAST paddings, take into account all this KMV XL technology, because in the end the paddings is defined as a freely moldable material. It's like a customized piece of material with the same technology as the KMV XL risers that enables the directional solidification and also lets the foundry to increase the feeding distance. We can identify in the picture on the right the blue and yellow cylinders as the riser of feeder and sleeve items. Then the gray plate would be the casting, and in this case the green part would be the padding. We have to imagine that the padding would have the same properties as the riser. So in the end, we can understand this padding as a material that can ensure the feeding of the bottoms area without changing the actual geometry of the casting. So there are several reasons for using a padding. This is quite a creative product. In the end, there are many reasons, but here are some. We can have the insufficient fitting distance. So the fact of having a padding designed accordingly could improve this fitting distance. We can also have a difficult to access residual solidification areas, maybe due to the geometry of the castings. There are some spots not easy to feed through risers placed on the top or lateral feeding devices. In the end, the padding can solve these needs of feeding in spot areas. Also, another reason is the one that we already mentioned, the fact of being able to feed a casting or a certain area of the casting without changing the geometry of it. Also, if we want to avoid this extra cost of adding the material, not only because of the cost of the material itself, but also because afterwards you have to remove this material. So we will have these flattening and cleaning costs. Another reason could be also the need or the desire of having lightweight constructions, or maybe we have not enough space or not good space conditions for placing the risers. So here we have one of the examples of the one use of a padding. So the idea behind was to keep the original shape of the casting, to be able to fit the whole casting, but not changing the original geometry. So if we see the standard layout, it consists of a traditional feeder and with an enlargement of the section of the casting to be able to have enough flow and feeding distance, let's say, to fit the bottom part. When designing corresponding padding for that area, we were able to keep the original shape of the casting, and of course we could save a lot of hours of cleaning and flattening costs. So the advantage of using a padding is, first of all, the flexibility. As I mentioned, this is a quite creative product that has a high geometry degree of freedom. It can be adapted to any shape of the casting, and in the end, it lets the foundry to avoid any changes in the original component. These paddings, as they share the same technology and properties like the risers, could be also combined with the KMV XL risers, and they can be also used in core sections. Talking about efficiency, these paddings are really easy to produce. They can be produced in the foundries. It has also brings the possibility also to enlarge the portfolio of the foundry. And the most important one of the most important things is the possibility to fit these difficult areas. From the economic point of view, we have a clear yield improvement when using these paddings. We save cleaning costs and flattening costs due to the reduction of these extra parts or extra materials needed with oil designs, and we can reduce the weight component. So now we will explain how both the EXACTCAST KMV XL and the paddings are really a perfect match. So the reason for using these two products together is because we can benefit from both technologies, both properties, and in the end, we can apply a really premium solution to high demanding castings in terms of quality, in terms of yield optimization. This can have really tailor-made solution for each casting, each section, or each application. In the end, has a lot of freedom of design. In the end, the combination of both technologies can also let the foundries to access new markets, and in the end, this will improve the foundry's competitiveness. The advantage of the use of this perfect match, the KMV XL with the paddings, has, first of all, a flexibility matter. I mean, these customized assembly are really fitting the needs of each casting. This is a really a premium solution in terms of quality. We are using the most optimized solution for each foundry and each casting. We can have this tailor-made solution together with the design. We can also apply this to spot areas, really having the best results. And in the end, we will have the possibility to access new markets. Talking about efficiency, compared to other feeding systems, we can increase the feeding performance. It's important to know that both KMV XL risers and paddings have this double performance in terms of exothermic and insulating properties. So in the end, this will have huge performance. This will increase the feeding system distance, including the riser together with the corresponding padding. And from the economic point of view, we are able to reduce the cleaning operations and improve the quality of our castings. Now we will go through some success stories that can support these theories. First of all, we have a first case study consisting of super duplex casting of 900 kilograms and 3 positions of risers. The original design was consisting of a traditional fiber device with a volume of 4.5 liters. And in this case, the solution proposed was to use a KMV 2565 with 2.5 liters. In the end, once the casting was checked and everything was okay, the foundry was able to have 45% of feeding savings. In the end, per casting, they were able to save up to 50 kilograms. And in the end, in the whole series, all the savings was quite interesting, taking into account that we are talking about the super duplex alloy, that is quite an expensive one. In this second case study, we are also talking about a steel foundry in Europe. In this case, the casting was a manganese steel one with a total weight of 1 ton 0.6, and the layout consisted on 10 riser positions. In the first trial, we wanted to make only the change of one of the positions from the traditional solution consisting on a neck down with 90 kilograms with the KMV 2565 with a total weight of 20 kilograms. In the end, the results were great. And when changing in the following pourings all the positions with this KMV XL technology, we were able to save almost 700 kilograms per casting. In this third case study, we show you the combination of the KMV XL risers together with the paddings. And this trial was made in another steel foundry in Europe. This one was a low carbon steel casting with a gross weight of 18 tons. Again, here they have like 10 positions of risers, and those risers were a KMV 34,500. This means that each riser had 34.5 liters of metal. And together with the risers, some paddings were designed to have like 2 functions. First of all was to increase the feeding distance and be able to feed the lower part of this ring. And the other function was to help the position of this big riser on top of the ring. You can see on the pictures how was the layout of this assembly. In the end, the challenge was really not to change the geometry of the original casting and be able to feed all the casting with the risers on top. In the end, compared to the original traditional feeding systems, they were able to reach this 48% of feeding savings. And the most important thing was the 30 hours that they saved due to the cleaning and fletching operations. In the end, this foundry was much faster from the foundry process to the delivery process. So in the end, they really have a lot of benefits using this combination of products. So now we will go through the conclusions before we end this webinar. So the use of this technology, no matter if we use it in the shape of the KMV XL or the padding or both together, in the end we will have these benefits from the environment point of view. We have the possibility to have no fluorine in content in the materials. Of course, no fibers in it, and we can address CO2 reductions. Emissions reductions due to the yield optimization of the castings, to the reduction of the feeders. In the end, we are avoiding the melting of extra metal. So this is a quite important point. Talking from the efficiency point of view, we are talking about a premium solution that really fits the needs of any situation, any geometry. So it's really efficient for those particular applications. And the fact of having this insulating capacity makes the difference with other fitting devices. From the economic point of view, we are maximizing the yield of the castings. Thanks to the use of this combination of risers and paddings, we also bring the possibility to the foundries to increase the melting shop capacity. As they are reducing the fitting systems, they are able to open new markets and be able to pour bigger castings. This also leads to energy cost savings, as we are reducing the gross weight of the castings, and in the end, this will bring an improvement of competitiveness to the foundries. So I would say thank you, everyone. Udo, now
yes, okay, Emmanuel, thank you for this really interesting presentation. Also, thank you, dear guest, for your attention. We hope that this information was and will be useful for you. Such a big topic can, of course, only be touched here and stimulate you to think a little bit about it. But we would be happy to give you more and detailed information directly at your foundry to suit your individual needs. Also, this was one of the questions I saw in the as in Q&A part. And this is exactly what we are doing now. We are coming now to your questions. We have, yes, and this is perfect, we have here some. There are a couple of more or less similar questions, so I will combine them a little bit together, and I will say the things are all around. Are the riser and the paddings are compatible with all alloys, Emmanuel?
Yes, of course. We were talking mainly about the shapes of these items, the risers and the paddings, but behind this we have also different formulations, and the formulations are designed to have different performance depending on the alloys. So we can have, for instance, fully insulating recipes that would be compatible with aluminum applications, for example. Or on the opposite, we have highly exothermic applications formulations for those, for example, steel applications with higher demands. So in the end, I would say yes, these products are fully compatible with all alloys.
Okay. I hope this will clarify 2 or 3 questions about ductile iron, steel, and all different alloys the auditorium are asking for. Another question here is how ASK is delivering the padding. So what is how we bring it to customers?
Yeah, the padding, as we mentioned, is a free moldable part. So in the end, the design of it, the shape of it, should be agreed with the customer because it fits the needs of a particular casting. So this is not the default geometry that we have in our portfolio. This means that in most of the cases, we can provide the material to produce the padding to the customers, and they can make it by their own with not big investments because it's easy to produce, and it's just could be done, for example, with cold box or with phenolic urethane no-bake binders, and in the end, this can be done manually. It could also be the possibility that we can produce these paddings for the customers if we are talking about a big series or if there is an interest behind of doing it in this way. So we are open to work in these 2 ways. We can provide the materials to the customer, or we can just do the paddings for them.
Okay, so your answer also here was another question about the which kind of binders are the best one for the padding materials.
Yeah, this is an important point. Not all the binders are good or compatible with this material. In the end, our recommendation always is to use a phenolic urethane systems, no matter if we are talking about a no-bake one or a cold box one. Also, the LinoCure system is compatible. And also the silicate binder could be also compatible. But in this case, when talking about the silicate binder, we have to remark that we are adding water to the mix somehow, and in the end, we have to be careful when using the padding in contact with the casting. Maybe we could have some skin defects, but our recommendation would be always to use a phenolic urethane no-bake. But if there is any particular question behind, please do not hesitate to contact us to make a study and see the conditions of the application, so we can recommend the best binder system for you.
Okay, I hope this is clearer now. Here are also 2, 3, 4 questions around simulation software and how to calculate it and so on, which data we gave to our customers.
Okay. Yeah, these materials are fully compatible with the simulation software. In the end, we have to understand that the paddings are like an extension of a riser. So, for example, talking about magma, once we find the formulation or the material in the library, we can design the shape we want as a padding, and then tell to the software that this piece of material, it's like, for example, I say EXF formulation that is available in a library. So we can have the same properties in the material we design as a padding, so we can have simulating results for sure.
Okay, so here also there's someone find out that we give this data in very freshly to Novocast, and also we have it in Magma. So I think we can clearly say yes, the data are in the simulation software and you can use it, and so you can really try there at first. There was another question about how the material works in the green sand system. Is it a problem or not?
Not at all, not at all. These risers has been used since a lot of years, more than 15 years, in all type of molding lines with no issue. It's important to remember that these products, both the Paddings and the KMV XL risers, are very low weight materials, and during the shakeout of the casting together with the sand, part of the material, due to this low density, goes away with expiration, and the rest that goes into the sand circuit has no negative impact in the sand circuit.
Okay. Another I think, very good question. Is there a cover or a coating necessary to use the product?
Well, in the end, when we are talking about both risers or paddings, for me, it's like another part of the mold. So normally, the foundries or the customers used to apply a coating to the mold just to protect the castings from the mold, talking about the chemical influences. And I would say that both the paddings and the risers should be also covered with a coating. I mean, it's the same protection needed to the castings. Our recommendation from the ASK is that we use zircon coating. So it could be applied both to the mold and together with the coating, together with the paddings and the risers. And this will have no negative influence in the performance of both the products. So it's fully compatible with the coating.
Okay, and here another question, but it more or less in the same direction, is especially aluminium in the steel at the surface is also no reaction when we cover it with these coatings.
Yes, I mean, it is true that there is a chemical influence between the liquid metal and the elements from the mold. Could be the binder from the mold, or could be elements from the riser. In this case, it's good to have this zircon coating applied to the risers and the paddings to avoid this chemical interference between the aluminum going into the steel. Nevertheless, as I mentioned before, if we were talking about alcohol coatings or water glass coatings, this will have no influence in the terms of ignition time or maximum temperature or insulating capacity. So our recommendation is use this zircon coating. Yeah.
Okay. What is with carbon? Is there an influence when we have steel variations here and coming from the binder or from the padding material?
Nothing to report. I mean, not especially increased due to the use of it. I mean, would be the same like the carbon that we can have in the skin of the casting if we are using a cold box binder or a phenolic urethane binder in the mold. So in the end, nothing special. Not really that much.
Okay. And here again, a little bit about the simulation softwares. I think the question is after other software like 3D Flow or what is coming on now in the market. So I can directly answer it. We start with every producer of the software to be really in a short time everywhere in. I hope this answers the question. Then another question is it possible to make this presentation also at the customer or in a university? I don't know exactly from whom this question is coming.
I guess we have no problem to make this presentation in the customers in the end is part also of our job to show the last state-of-the-art products that we have that are really giving a lot of benefits to the foundries. So in the end, we are also open to make more diffusion of this information, of course.
Okay, I think there's only one left, but I think we spoke a little bit about it, how you get the material into the right form. Yeah, so.
Okay, talking about the paddings.
Yes.
Yeah, talking about the paddings, there are several ways of working with it. In the end, from the scratch, we are talking about a solid mixture, I mean, consisting of a kind of a special powder that is mixed with a binder. Then this mix could be shooted in a standard core box automatically, like any core box made of sand, or we can do it manually in a kind of wooden box. But there are many ways of making it. But in the end, it's important to know that the cold box is the most compatible system. And in the second hand, the phenolic urethane no bake, we call it a PEPSET binder. And of course, if it is necessary, we can also try to make it with phenyl alkaline. It's not desirable, but the way of giving it shape is to have a kind of a tooling. Could be made of wood, made of steel. It will always depend on how big the series is. We are talking about a couple of paddings or 1,000 or hundreds of paddings. So, but please do not hesitate. Also, please to contact us because we can give you further tips and explanations.
Okay. Unfortunately, we have to come to the end with a look to the current time. There are still some questions, especially about simulation. So I'm feel that we make a webinar exactly about these things, how to use and what are the difference. I will really make it very shortly because we need now to come to an end. All the data are different. It's depending on the simulation software. So we have different data by different simulation softwares because they work everyone very individual. So we need different data. Also, we looked into the breaker cause data. The most are in the basic data from the simulation maker. I think here we must go in details a little bit more with a special webinar. So I feel that here is really the demonter. We could not answer all questions, but we will get back to you shortly. Promise. As an important addition, I would like to draw your attention to the fact that there was already a separate webinar on the subject of padding. Luckily, you can still download this special webinar from our website. In the end, we would also be happy to help you personally if you leave us a message on the website. Ladies and gentlemen, hope you enjoy this today webinar. Thank you very much for your attention. Again, don't forget to check our website from time to time so that you doesn't miss any ASK Academy webinars that might be of interest to you. I would also like to thank our technical director today, Verena Sander, and wish you an entertaining rest of the week, and please stay healthy. My name is Udo Skerdi. I hope we meet again shortly. Goodbye.